you do analysis and design for that. That is software engineering. Is somebody saying, yeah, please keep on putting your attendance on the chat box with your enrollment number, name, right? Enrollment number and name, please put it in the chat box for attendance. Right. So what is analysis? If you have done, so if some of you must have known about software engineering. So in software engineering, we used to analyze, first was a requirement analysis, or finding out the requirements, then analyzing the requirements, then designing it, then coding it, right? That is implementation. And then you do maintenance, testing and maintenance. So that those were the phases in software engineering. Same way in object oriented analysis also, what we do is we we first find out the requirements, then analyze the requirements according to the software, right? The technical steps of developing the software. That is known as object oriented analysis. Right, the primary technical step in developing a software system using the object-oriented approach. That is object-oriented analysis. Right. Then we do object-oriented design. So first we find out the requirements, we analyze the requirements, whether we can make the software or not. After analysis has been done, the study, feasibility study, everything has been done, then we design the software. So in object-oriented, then we do object-oriented design. So design is like we create a model, a prototype, you can say. We create a model on which the actual coding will be done. After that, the actual coding will be done. So first we design the model, how our software will be looking like. So object oriented analysis is transformed into design model that works as a plan for software development. Right. So first we do analysis, object oriented analysis, finding out the requirements, whether we can make the software or not. After analyzing everything, then we design it according to a plan, or according to there are different diagrams and different diagrams which are used in object oriented modeling, right? So we will talk about those diagrams also. So in design, we will design according to those diagrams, and then the final thing, because we are only doing analysis and design, we are not talking about the implementation or coding part. So we will be talking about analysis and design. So object-oriented analysis and design methods, they emerged in 1980, right? And object-oriented analysis methods emerged during the 1990, right? So they have given you the different methods or the concepts emerged in 1980, and the analysis methods came in 1990, right? So they have talked about that, what is object-oriented analysis and design, right? Then they are talking about object orientation. So object orientation, we have many approaches in object-oriented analysis and design, right? They are object modeling technique, OMT, for software modeling and designing. And it was suggested by James Rambach in 1991. So this OMT technique was developed by this James Rambach in 1991. He suggested three types of models. So in object-oriented modeling technique, which is one of the approach of object-oriented analysis and design, he said there are three types of models: object model, dynamic model, and functional model. So there are three types of models in OMT, object modeling technique. So we'll be talking about one by one: object model, dynamic model, function model. What are they? Another approach, so there are two approaches basically. One is object modeling technique suggested by James Rambach. The another approach was Booch methodology, which was developed by Grady Booch, right? So Booch methodology, which is again object-oriented analysis and design methodology, right, was proposed by Grady Booch, right? So these are the two approaches under object-oriented modeling technique, right? So the OAD approach is sequential in nature. What does sequential means? That you have to follow one by step one, then step two, and step three, right? Sequentially, one by one. The analysis phase establishes the system requirements and performs domain analysis from the customer perspective. That means you have to find out the requirements from the customer. Once the analysis phase is complete, the design phase, which is iterative in nature. So basically, analysis phase is sequential in nature. because you have to one by one find out the requirements and perform the analysis, whatever the customers, according to the customer's perspective. Then you have, from the analysis phase you go to the design phase. So design phase is iterative in nature. That means you have to repeat the process if there are some missing things, there are something which you have not taken care of according to the requirements. So it is iterative, repetitive, right? So it maps a logic design to the physical design, right? So the prototype is created and tested. So after you have created the after the analysis phase, when you go to the design phase, you create a prototype which is created and which is tested also. So it is one of the widely used approaches in object oriented software engineering, right? So that is there. So another popular approach after this, your the two approaches of object modeling technique, one was the OMT. One is OMT of OAD approach is OMT. The other is the Gooch methodology, Grady Gooch, which proposed. The another methodology they are talking about is object-oriented software engineering, OOSE, object-oriented software engineering, which was proposed by Ivor Jacobson in 1992. This was another approach. It was first object-oriented design method that was made use of, that is use case diagram in the design. The phases included in his approach include requirement gathering, analysis, design, implementation, and testing. So these were the phases which were used by Ivor Jacobson, and he also used certain diagrams like use case diagram he used for making the design phase. Right. So we'll talk about them later on. The details will be given. Then we are trying to understand now object-oriented modeling. What is object-oriented modeling? So we may find an entirely new way of thinking about problem analysis and creating a system model. The OM methodology is about visualizing things using models organized around real world concepts. So basically object oriented, object is a real world entity, right? So we are visualizing OOM, that is object oriented methodology, is actually visualizing things using the models organized according to the real world concepts, right? So object oriented models help understand the problem, communicate with domain expert from a distance, model enterprises, and design the layout of the computer programs and databases. So that is what object oriented modeling does. So basically you are analyzing, then creating a model, right? So you're communicating, you are understanding the problem, you are designing the layout of the program. That is what object oriented modeling basically means. So object oriented models are represented using standard, this is standard diagrams. A good model is always helpful in communication among projects teams and assures architectural soundness. So basically we'll be talking about the different diagrams which are the standard diagrams later on. Those are known as your UML diagrams. So we'll be talking about that, right? So the object modeling technique covers aspects of object-oriented analysis and design. OMT provides a very productive and practical way of software development, right? The best way, best part of object-oriented technology is that it is not language dependent, because we are not talking about the coding part. So we are not talking about which language you will use. So it is not dependent on the language. We are talking about the analysis and design part, right? So we have different diagrams and we have different methodologies for analysis. So we'll be talking about those. So there is no need to consider a final implementation language during object oriented modeling. So that is what they are talking about. Then they are talking about the analysis helps you to ensure your system works in real world context, right? So OOT, that is object oriented technique, combines structural, control, and functional aspects of the system. So we'll be talking about all those in block 2 and block 3 also. We'll be talking about different diagrams later on. So I'm not going through everything. You can read this, right? So we'll then they are talking about object oriented modeling and design. So, what is object-oriented modeling and design? So, it consists of the analysis and design phase. Object-oriented modeling and design consist of analysis and design phase, which are related but distinct. They are related to each other, but they are different in their concepts. So the first step of OOAD, that is object-oriented analysis and design, is identifying requirements and developing an object model of the application domain. That is OOA, analysis phase. So object-oriented analysis phase is you are identifying the requirements, developing an object model of the application domain. Object model means we'll be talking about the what is object model. So object model means you are finding out what are the different requirements, what are the different objects you are having in your project. So that will be your analysis phase. Then software requirements are established during analysis. So whatever the software requirements are, all the requirements will be gathered. So that is your analysis phase, right? So you will understand the problem and find out the different requirements. The next step is OOD, that is object oriented design. So object oriented design is now you have to construct the object, or you have to make a model or a diagram to show that how your system is working. So an object is the instance of a class and contains data structure in addition to its behavioral characteristics. So object can interact with each other to design various applications and programs. So you will talk about object, we'll talk about classes, and there are different other diagrams. So we will talk about the object oriented design, how the design thing is done. So object oriented modeling, if you talk about OM, object oriented modeling is divided into various stages. So you can be asked in the theory examination that what is object oriented modeling and what are the different stages of object oriented modeling. So object oriented modeling is explained above. Then object oriented modeling have different various phases, like stages like requirement analysis of the system, designing of the system, detailed designing with a focus on objects in the system, and implementing the model. So these are the different phases of object-oriented model. Like you have in your software engineering, if, all those people who know, in the first semester, you must have studied software engineering. So all those phases are similar here, only a little bit difference is there. So requirement analysis is there. So you will gather the requirements first. Then you will analyze the requirements, right? Requirement analysis of the system is done. Then you in the analysis phase, you make an object model, dynamic model, and functional model. In the analysis phase, you make an object model, dynamic model, and functional model. After that, the detailed designing with a focus on objects in the system is done. So you will make through the object model and dynamic and functional model, you will design architecture design and object design. You will make up from this, right? Then implement the model. So after that, you implementing means coding in any object oriented programming language, right? So this is what your object oriented modeling phases are divided: requirement analysis, designing, then detailed designing with focus on objects and all that. So they have explained the different things like system analysis. At this stage, a problem statement is formulated and the analysts build a system model to encourage real world situations. This phase shows the essential properties associated with the situation. The analysis model is a concise, precise abstraction and agreement on how the desired system must be developed. So analysis is basically you know what is the problem. Basic problem is formulated, and then you analyze that the system that it on the real world situations how the system can be built, right? So that is there. Then in the system design, during the stage, the complete system architecture is designed. System design, whole system is divided into subsystem based on both the system analysis model and the proposed architecture of the model. So basically in the system design, you will design this architecture of the system, right? And you will divide your system into subsystem, and according to that, and based on the analysis model only, the system design will be done. Then you in the system design, you do object design. So during the this stage, a design model is developed based on the analysis model already developed in the earlier phase of the development. The object design decides the data structures and algorithm needed to implement each of the classes in the system. So basically in object design, you will decide what are the different classes, what are the objects in the classes. So all these will help you decide the data structure and algorithm of your system, right? So the steps followed in object designing are as follows. Procedures or operations performed on various classes are identified and finalized. So you will find out the classes, their objects, the functions or operations or procedures which will be performed on these classes. Then the logic required to implement the procedure gets decided. What is the logic through which the procedure will be implemented? All the paths for retrieving data are optimized. A list is prepared for all the permitted external interface. Classes and their associated operation are rearranged or adjusted to increase the inheritance properties between classes and the objects. Packaging of all associated classes is done in a single module. So you'll find out the classes. You can also make a package. A package is a collection of classes, you can say. Collection of classes, associated classes are made in a module or a package. So that can also be done. So all these are part of your object designing, right? Then, because you have designed this after system design, the next step you will do is implementation, that is coding. But in this object oriented analysis and design subject, you will not be coding anything because you will be only analyzing and designing. But later on stage, the next thing in your analysis and design is implementation. So at this stage, the final implementation of classes and relationship developed during object design takes place using any particular programming language. So you know what are the different object oriented programming language. You have C++, Java, then Python also follows object oriented programming, right? C sharp is there. So there are different languages which you can use for implementing. Then object modeling technique. So what is object modeling technique? We talked about that object modeling technique have three kinds of models, right? So the models are object model, dynamic model, and functional model. So object models, for the first one, the three models which are there in your OMT, that is object modeling. So object models are used to describe the objects and their relationship with each other in the system. So in an object model, you will find out the different objects and their relationship with each other you will show. That is object model. The dynamic model describes the interaction among objects and information flow in the system. So how the objects are interacting with each other and how the information is flowing is shown in dynamic model. And then is the functional model. So the functional model describes the data transformations in the system, that how data is transforming or changing in the system is from one stage to the other is your functional model. So all three models are applicable during all the stages of development, right? So these models bear the responsibility of acquiring implementation details of the system development. So these are the three models which you should know. You can be asked what is OMT, object modeling technique, and what are the three models. So this is object model, dynamic model, and functional model. So this is there. So in object-oriented development is an indirect way of system development, because in this approach, a holistic view of the application domain is considered and objects are identified in the related problem domain, right? So we have to find out the different objects which we are finding out. So taking a holistic view of the problem domain rather than considering the functional requirements of a single problem given an edge to object-oriented development. So why object-oriented development is better than procedural or function development is that it takes objects into consideration rather than the functional requirements. So first it will take the problem, so the holistic problem domain rather than considering the functional requirements which are there for the problem. So once the objects are created with the needed characteristics, they communicate with each other by message passing during problem solving. So that is the main thing which is there in your object-oriented development. So we talked about object model, dynamic model, functional model. There are again explaining you the three models of OMD which we talked about here: object model, dynamic model, functional model. So in object modeling, what all you will do, every object has some attribute and behavior. Some common examples of objects include car, student, banking. Whatever you see in the real world is an object, a real world entity. Whatever you are seeing, a car, student, bank, banking, book, teacher, employee, whatever is there is a object. So we can perform many functions on the object, including its categorization, description, organization of objects. So we can do anything, combining, manipulating objects, whatever you want to do, you can do with the objects. So the object model can be represented graphically with the help of class diagram. So in object modeling, which diagram you will be studying will be the class diagram and object diagram. There are two diagrams of class diagram and object diagram, which are part of object modeling. So we'll be doing that. Right. So object modeling will be discussed in unit 6 of this course. So they have given you in which course you will be doing object modeling. Then they're talking about dynamic modeling. So it is considered with time, state, and transition from one state to another. So dynamic modeling is that how the data is transferred, right? So we talked about dynamic modeling here. So dynamic model describes the interaction among objects and information flow in the system. So that is what dynamic modeling does. So time, state, and transition from one state to another is dynamic modeling. So events that trigger the transition, actions that happen after the event occurred and are instantaneous. So in the dynamic model, we'll be talking about state transition diagrams. There are different diagrams in dynamic model. So that will be discussed in unit 7. Then functional modeling, the information is then the in functional model we are talking about the data transformation in the system, how data is transferred from one to the other. So it represents how the data flow from one operation to another. So this is shown through DFD, data flow diagram. So we'll be talking about data flow diagram also in software engineering. In the previous first semester also we talked about data flow diagram. So here also the functional modeling will be having DFDs. So we'll be talking about that in unit 8. So that is there, right? So now they are talking about the basic philosophy of object orientation. Philosophy means the basic concepts. So there are several characteristics of object-oriented technology. So they are talking about the different characteristics, you can say, or the different philosophies, you can say, or the concepts, you can say. The sharing of structure and behavior. One of the reasons for popularity of object-oriented technique is that they encourage sharing at different levels. So inheritance is one of the main advantages of any object-oriented language. So you know that what sharing of structure and behavior means: reusability. Reusability means, if you know about the concept of inheritance, one of the concepts of object-oriented programming, in inheritance means that from a parent, the child inherits the parent's properties and the child also has its own properties. Right. Same way in inheritance, that is the one concept of reusability, that one of the if you have a parent-child relationship between classes, so the base or the parent class can share the things with its child class. The child class can access or inherit from its parent class, right? So if you have given some code in the parent class, that can be accessed in the child class if there is a child of that parent. So that is what inheritance concept is. So inheritance of both data structure and behavior allows common structure base class to be used in designing many subclasses based on essential characteristics of the base class, develop new classes with less effort. Right. So that is one concept of sharing of structure and behavior. Right. Emphasis on object structure, not on operation implementation. So in object orientation, the major emphasis is given to specifying the characteristics of the object in a system rather than implementing these characteristics. So what they are saying is, we are basically having emphasis on object structure, right? Rather than the function or operation of implementation. So first we will be talking about the different characteristics of the objects rather than implementing these characteristics first. So uses of an object depend highly on the facts of the application and regular changes during development. Just hold on for a second. Yeah, sorry. So emphasis is basically on object structure rather than its implementation. That is the main concept of object-oriented analysis or object-oriented approach. Right. So these are the two characteristics they have talked about: basic philosophy of object-oriented, sharing the structure and behavior, and emphasis on object structure. Then they are talking about the principles of object orientation. Principles means concepts. So the principles which are there for object orientation are abstraction. First principle is abstraction. So abstraction is one of the very important concepts of object orientation system. Abstraction focuses on the essential inherent aspects of an object of the system. So it does not represent the accidental properties of the system. In system development, abstraction has focus on what an object is supposed to do before deciding how it should be implemented. Right. So that means you are the most important aspect of the abstraction is the objects. Right. The focus is on objects. So we are not the same thing, which is this emphasis on object structure. The same thing is abstraction. Right. So they are talking that object is the main focus rather than implement. How it is implemented is not right now the focus. Before that, how it is implemented, our focus is on the object. So the use of abstraction protects the freedom to make decision for as long as possible by avoiding intermediate commitments in problem solving. So most modern language provide data abstraction. With the abstraction, the ability to use inheritance and apply polymorphism provides additional freedom and capability for the system development. So when we can see abstraction in the real world all the time, and we just do not think of it in that specific way. One very common example you may take: when you interact using your mobile phones, all you do is open an application and press a button to make a call. Actually you are performing a simple task, but in reality a lot of things are happening that you may not know or do not need to know as a used user. So basically abstraction is that you are just showing the or you are just using the uh, uh, thing, but you don't know actually how that thing is working in the background. So like you drive a car, so you know how to use the brakes or accelerator or clutch or steering, but you don't know how actually the engine, when you press the clutch or when you accelerate, what how the engine is working, how everything is working in the background. You don't know the details, you don't know in the background, but you know how to drive it, how to use it. So that is what they are talking about. So same way that they are talking about that, you know how the mobile applications are working, how to make a call, how to do this, but actually in the background, what how they are implemented, how they are working, you have no idea. That is what abstraction is: hiding the details from the user and showing the necessary things which they are going to use. That is what abstraction is. This is one concept. Then we are talking about encapsulation, the another concept. So encapsulation or information hiding is a principle by which we hide data that we don't want the user to see and show data that we want them to see. So it is the feature of separating the external aspects of an object from the internal implementation details of that object. So encapsulation is, or it is also known as information hiding. So like a class, if you talk about a class, so a class is a blueprint or a container which is holding the different objects and the implementation of that objects inside it. Right. So you have in a class, if all those who know about object oriented programming, so when you create a class you have different access specifiers: public, private, protected, right? So if you have made it by default in a class, it is private. Private means you get the things inside the class cannot be accessed outside the class until and unless you make it public, right? So that means you are hiding certain details inside a container, and that is known as information hiding, and you cannot access this outside until and unless you give an access to that particular thing, right? So encapsulation or information hiding is a principle by which we hide data that we don't want the user to see and show data that we want them to see. So only things we want them to see will be made public, and the things we don't want them to see will be made private. So that is encapsulation. Class is the example of encapsulation, how encapsulation is implemented, hiding the things, right? Then we are talking about the next concept, which is known as inheritance. So right now I just explained inheritance also. The inheritance is taken in the sense of code reuse with object oriented development. So I told you that inheritance is inheriting from the parent to the child, right? A parent cannot inherit from the child. A child can inherit from its parents, and the child can also have its own properties also. Apart from the properties it is inheriting from the parent, the child can have its own properties also. So it is basically used for code reuse or reusability. So, generalization, specialization, and inheritance have a very close association. Generalization is these are the two concepts which can, or an inheritance. These are the three things which are there. There are close association with them, right? And a theory question can be asked: what is generalization? What is specialization? What is inheritance? So generalization is used to refer the to the relationship among classes, and inheritance is used for sharing attributes and operation using the generalization relationship. So basically, inheritance and generalization are similar. Generalization is basically the you are showing the relationship among classes, that this is the parent class, this is the child class, right, for sharing the attributes and operations. So similarly, inheritance is basically you are sharing the attributes and operations using generalization relationship. So in respect of inheritance, generalization and specialization are two phases of a coin, in the sense that if a subclass is seen from the superclass, if you are seeing subclass from the superclass, so subclass is seen as, just hold on for a second. Class, just wait for 5 minutes. I'm just returning back. Just wait for 5 minutes.
कौन सा टॉपिक चल रहा है, कोई बताएगा?
Inheritance.
शुक्रिया भाई।
Yeah, sorry. So we were talking about generalization. So when we talk about specialization, so if we are seeing the subclass from the superclass, it is known as specialization. So subclass is seen as a specialized version of the superclass. But in reverse, if we see a superclass, right, looks like a general form of a subclass, then you will be seeing it like generalization. From bottom to top, if you see, it is specialization, and from top to bottom, if you see, that is generalization. So we will be seeing the diagram later on, right? So use inheritance when one object behaves like another, rather than just when is a relationship applies. So there they are saying that inheritance you will use when one object behaves like the another, rather than is a relationship will be taken care of in a different way, right? And inheritance relationship will be taken care of a different way. So that is what they are talking about. We'll be talking about that later on also. So during inheritance, a subclass may override a superclass feature by defining that feature with the same name. So sometimes what happens is you have a feature in your superclass, right? And you are implementing that feature, same feature in the subclass also, but with different implementation. So that is known as overriding. The same feature you are implementing in the subclass, but with different implementation. So that is known as a overriding feature. The same function you will also have in your subclass, but it will have a different implementation than the superclass. So the overriding feature, the subclass feature with the same name of the superclass feature, defines and replaces the overridden feature, the superclass feature. So you are overriding that. Whatever is implementing in the superclass, you are overriding that in the subclass. That is one of the concepts also of that is a concept of polymorphism, basically, you can say. So here they are defining a diagram to show how inheritance is implemented. So you have circle, you have triangle, you have square. So these are the three classes, right? And there is a class called shape, right? So shape class is your parent class, and circle, triangle, and square are your subclasses or child classes. So how do you show in a diagram is this is your shape class. Shape is the name of the class, and these are the methods or procedures or functions implemented in that class. Draw and erase in the shape class, right? And this triangle thing, triangle with a arrow like triangle, right? So this is how you show that this is inheritance, and this is the superclass. The arrow will be pointing to the superclass, and child classes are circle, triangle, and square. So shape can be a circle, shape can be a triangle, shape can be a square. So the main class is shape, and this draw and erase will be reused in circle also, triangle also. That means it can inherit the draw and erase methods in circle, triangle, and square. Circle will be drawn with different parameters, right? And erase with different parameters. Triangle can be drawn with different parameters. Square can be drawn with different parameters. So this draw and erase can be overridden in the square method. That is there. Then you also have different types of inheritance are also there. Right now they are not explained fully, the different types. You have single inheritance. This is single inheritance. One parent, sorry, not single inheritance, you can say you have multiple childs, but this is known as single inheritance only. One parent, one child, one parent, one child, right? When you have two parents, and from the two parents you are inheriting in one child, that is known as multiple inheritance. Fly things and run things are two classes: base class A, base class B, right? Two base classes. And from that base class, aeroplane is inheriting. A single child class is inheriting from two parent classes. So fly things is in aeroplanes is inheriting from fly things also. Aeroplane is inheriting from run things also. Same way, helicopter is inheriting from fly thing also. Helicopter is inheriting from run thing also. So this is multiple inheritance where you are inheriting from two parents. But car is inheriting from run things only. This is single inheritance, right? So multiple inheritance is also shown here. So they have shown you how multiple inheritance is shown. Then the another concept which they are talking about is polymorphism. So poly means many, and morphism means forms, many forms, right? So polymorphism is closely related to inheritance. When one class inherits from another, then polymorphism allows a subclass to stand in for the superclass. So the class hierarchy is deciding factor in the case of more than one implementation of characteristics. But that is one thing. Like we talked about overriding feature, right? So in overriding, what you are doing is you have implementation in the your parent class, but in the child class, when you are inheriting that particular method in the child class, that same draw method will be used in a different implementation. That is overriding. That is one of the concepts of polymorphism. Right, there are different types of polymorphism, like overloading, overriding, right? That is compile time polymorphism and runtime polymorphism. So when we talk about polymorphism, like you are using an add function, one of the name of the function is add. So one implementation of add will be that you are adding two parameters, two values. That is one implementation. If you are adding three values, that add function will be overloaded, and that add function is adding three values, or you can have four values. So there, this is different types of implementation of one function, same function name but different implementation. That is polymorphism, right? You can also say that one function is adding integers, another function is adding float, another function is adding complex numbers, whatever. Just an example. So that is known as polymorphism, implementing the function in different forms. Polymorphism. Right, like they are saying an object-oriented program to calculate the area of different figures would simply call the find area operation on each figure, whether it is a circle, triangle, or something else. The decision of which procedure to use is made implicitly by each object. So what they are saying is the same thing which they are talking here. So suppose there is a function called find area. So find area, in circle the area, to find the area it is different implementation, to find a triangle area is a different implementation, to find the area of a square is a different implementation. So that is done through polymorphism. That is what they are talking about. Right. So this is what they are talking about. So here they have asked you in check progress one, what is oriented modeling? What are the different steps of object oriented modeling process? The stages you can say, and then differentiate object oriented approach of system development from the structured approach of system development. So if you need to see the answers also in the check progress question answers are given at the end of your block here. So check your progress one. So what is object oriented modeling? They have given you. What are the steps involved in object oriented modeling? The analysis are given here, and what is the difference between structured approach and object oriented approach is given here. Right. So each check progress is given at the back of your thing. So then they are talking about basic constructs of object orientation. So after that is basic constructs means the different concepts or the object oriented modeling thing. The different concepts are like class and objects, links and association, generalization and inheritance. So they're talking about the basic constructs. So these are the constructs: class and objects, link and association, generalization and inheritance. So class and object, we know if we have done object-oriented programming or object-oriented things. So a class is a collection of things or concepts that have the same characteristics. So each of these things or concepts are known as objects, right? Object is a real-world entity. Collection of the similar kind of objects will be a class. Right. So class define the basic words of the system being modeled. Using a set of classes as the core vocabulary of software project tends to greatly facilitate understanding and agreement about the meanings of terms and other characteristics of the objects in the system. So class, we will be talking about UML, that is Unified Modeling Language, and how the class is made. We will be seeing the diagram also. So here they are talking about what all class have. The terms used in the class are attribute, operations. Right. So class have two parts. One is an attribute, one are operation. So attributes are your characteristics. Right. Just hold on for a second. Yeah. Sorry. So attributes are your characteristics, right? So suppose you have a this is your diagram how you draw a class. So there will be a rectangle kind of a block box, and that rectangle box is divided into three parts. The name of the class will be the first one, which is in bold. Then the second block will be attributes, and the third block will be operations. So attributes are the characteristics, right, of different objects of a given class. Typically have at least some differences in the values of the attributes. So like if this class is a student class, then the attributes will be student ID, name, date of birth, whatever, right? So those are your attributes, and operations will be that to study in the class, to take admission, whatever. Those will be your operations. that kind of a thing. Operation represents services that an object can request to affect the behavior of the object or the system itself. So these are operations are the services. Attributes are your characteristics, right? So here in the UML, that is Unified Modeling Notation, class is represented like this. This is a class notation, a box with 3 sections, right? The boldface will be the name of the class, and the second part will be attribute, third part will be operations, right? Like here they have not they have not given a actual example. We'll be going in the unit later units, then they will be giving you actual examples also. So you can have class and operations also, no attribute. You can have only class also. You can have class with attribute also, right? That is also allowed. So you can also show a class without attribute and its operations, or the name of the class can appear by itself. So these are the different things. So the naming convention, class names are simple nouns or noun phrases. That means class name like student, whatever, nouns or noun phrases. Attribute names in a class are simple nouns or noun phrases. The first word is not capitalized, and but subsequent words may be capitalized. So if you want, you can write in small letters also the attributes. So attribute can be student ID, name, date of birth. Those are your attributes. Operation names are simple verbs. Verbs means action, action taking things. So like draw, erase, implement, whatever, display. So those words will be your operation names, right? Then you also have object. So what is object? Object is a real world entity, right? So notation for object in UML, that how it is shown is like this. If you see here, there is a box with the object colon class name. So suppose if this class is student, so you will say object colon student. Within the top section of the class box, the name of the class to which the object belongs appears after a colon, right? The object may have a name. So like student name can be student 1. Student 1 colon student is the class name. We can say that, right? And the second section have the different attributes. So attribute 1, like student ID is equal to value will be 101. Name is equal to value will be Suman, whatever name you can give. The concept of top compartment are underlined for an object. So this is underlined, and each attribute defined for given class has a specific value for each object that belongs to that class. So each attribute will have a value. That is how the notation is shown, right? So if you look around, you will find many examples of real world objects such as your books, desk, television, whatever you can name it. So everything that software object knows and can do is expressed by the variables and methods within that object. So variables will be your the state or the objects, and the behavior will be your attributes, right? So you can say variables and methods. You can define methods also or operations in your class. So that is what is there. So they are saying, let us say that a software object that models your real world bicycle would have variables indicating the bicycle's current state. Its speed is 20 miles per hour. Its current gear is third gear. So something like that. So you will say here, what is the object and what is the class? What is the attribute? What is the value of that attribute? Like speed is 20 miles per hour, and second attribute is gear, and that is third gear. Something like that. Then communication by message passing. So you will agree that a single object alone is generally not very useful. Objects usually appear as component of larger program or a system. So through the interaction of these objects, the functionality of the system is achieved. Software objects interact and communicate with each other by message passing to each other. So when object X wants object Y to perform one of the methods of object Y, object X sends a message to object Y. So basically, if you have two objects, suppose there are two objects, one is this, another is this, they communicate with each other through message passing, right? That is what they are talking about. So an object characteristics are expressed through its methods. So message passing supports all possible interaction between objects. So it closes the gap between objects. Objects do not need to be in the same process or even on the same machine to send and receive messages back and forth to each other. So that is what they are talking about. To communicate with one object with another, we do that with message passing. Then they giving you the difference between object and classes. So what is an object? Object is considered as a physical entity. Class is defined as an entity that exists logically. Class is a collection of objects, similar objects. So it is logically, and objects are physical. Any number of objects can be created for a class. Class is declared once. One class is there, and a class can have many objects. Instance of a class is an object. A class is used to group similar objects. Right, object is an instance of a class, and class is used to group the similar kind of objects. So that is what the difference they have given. Then what is link and association? The next principle. Link and association. Link and association are the basic means to establish relationship among objects and classes of the system. Right. So a link is a relationship. Like student is registered in university. So student class is there, university class is there. So what is the relationship between both of them? There is that student registered in university. This is the relationship, association. This is a link. So link is a line. Link is a line between two classes. So this is what link is. A link is a physical or conceptual connection between objects. For example, a student named Shrikant study in IGNOU. So mathematically, you can define a link as a tuple, that is an ordered list of objects. Further, a link is also defined as an instance of an association. So it is an instance of an association. In other words, you may say that an association is a group of links with a common structure and meaning. For example, a student studying in a university. All the links in an association connect objects from the same class. A link is used to show a relationship between two or more objects. So this line is the link, and it is an instance of an association. So association name will be there, that what link is created between the two classes. So association and classes are similar, as classes describe objects and association describe links. Right, so this is what how association is defined. Note, every association has roles. So this is your role, that is student role, and university role can be there. So student study and university teach. These are the roles. This is the association name, and these are the roles which are basic thing which the student does and what the university does. So note that every association has roles. For example, in figure 1, two classes, student and university, have their defined roles. Here you can also see that binary association have two roles, one for each class. So this is kind of a binary association, two roles. Student study and university teach. Right. Then association may be binary, ternary, or have high order. So this is a ternary relationship. If you see here, 1, 2, 3 classes are connected to a relationship. A diamond, in between a diamond is there. This is a ternary relationship. So, but a ternary association is formed compulsion. It cannot be converted into a binary association. So if there is a ternary relationship, you cannot convert it into a binary. Right, between two classes, you cannot create that. If a ternary association is decomposed into another association, some information will be lost. So if you convert it into some other association from the ternary, some information will be lost. So you have student, teacher, and class. The three are have a relationship. Three of them have a relationship. So that's why they are made in a ternary association. Student are taught by the teacher, and students study in a class, and teacher teaches in a class, whatever. So ternary relationship is there. Right, so this is association, link and association. And then you are talking about multiplicity. What is multiplicity? Multiplicity is an association specifies how many objects participate in a relationship. Right, multiplicity decide the number of related objects. Multiplicity generally explained as one or many. Like how many students are taught by how many teachers. So the number you are finding out how many objects participate in the relationship. So many students are taught by one teacher, can be one kind of a thing. Or so what are the different multiplicity indicators? Is 0 or 1, 1 only, 0 or more, asterisk means more, 1 or more, right? only n means greater than 1, matlab any number. N means any number. 0 n means 0 to n, any number. 1 to n means 1 to any number. More than 1, that means. Right? So in association, general movement in both the directions of the relationship, but if you want to be specific in any particular direction, you have to mark it with an arrow like this. Right? Association movement is in one direction, so you have to mark it. The arrow is going from student to program, not from program to student. So you have marked it with an arrow like this. And you have also shown that one student can apply for many programs, 0 or more programs. So multiplicity is also given here, 0 or more program. We'll explain this diamond thing, which is in the relationship. This is actually aggregation. So we are talking about here aggregation also. So aggregation is a special form of association which models a part or whole or a part of or has a relationship as an aggregate, the whole and part. The is a relationship refers to inheritance. Is a relationship is inheritance, and part of or has a relationship is aggregate, right? Whole and part. So, and has a relation refers to aggregation or composition. So, there are two types of association. One is aggregation, the other is composition. The most considerable property of aggregation is transitivity. If X is part of Y and Y is part of Z, then X is also part of Z. So, this kind of a relationship, a part of transitivity, is also one of the property of aggregation. So aggregation is seen as a relationship in which an assembly class is related to a component class. In this concept, objects do not have separate existence and depend on composite objects. So if you see here, exam schedule does not have a separate existence, right? So exam schedule is part of candidate, right? So this is a whole part candidate and exam schedule is part of that candidate. So this diamond thing is how aggregation is shown. That exam schedule is part of the candidate object or class, right? So this is known as aggregation, right? If and what is composition? Composition is, suppose this part, the exam schedule can exist separately also, and it is part of a candidate also. It can exist separately also. But if there are certain objects, certain class which cannot exist without this whole part, it cannot exist separately from the whole part, then it will be a composition, and composition is shown with a filled diamond here. A black diamond will be created, that is known as composition. That means this class is not existing until this class is there. But here the composition is not there because exam schedule can be there separately also, but it is also part of the candidate. That is what association and composition are there. There are two types of aggregation and composition. Sorry. Then you have generalization and inheritance. This is another thing. Generalization is similar to inheritance. So generalization and inheritance are powerful abstraction for sharing the structure or behavior of one or more classes. That means you want to do reusability of code. Then you are doing generalization and inheritance. So generalization is the relationship between a class and it defines a hierarchy of abstraction in which subclasses, one or more, inherit from one or more superclasses. So generalization is basically a relationship between classes, right? You are defining a hierarchy that this is a superclass and it is inherit, and these subclasses are inheriting from the one or more superclasses or one superclass. Generalization and inheritance are transitive across a subjective number of levels in the hierarchy. Generalization is a kind of relationship. For example, saving account is kind of account. PG student is a kind of student, right? So you have account, which is one of the parent class, and you have saving account and current account. Two kinds of accounts are there: saving account, current account. So these are the child classes. This is a super class. So inheritance is shown with a triangle like this. So the notation of generalization is a triangle connecting a superclass to its subclass like this. A line connects the superclass to the top of the triangle here. Lines connect the subclasses to the horizontal bar. like this, attached to the base of the triangle. Generalization is very useful construct for both abstract modeling and implementation. So this is how generalization is shown or inheritance is shown, right? So this is generalization. Now, identifying classes, they are talking about how do you identify the classes. So, general practice to identify the classes in system include textual analysis when you look for nouns and verbs in your use case to figure out classes and related methods is called textual analysis. When you have a good use case, complete textual analysis is a quick and easy way to figure out the classes in your system. So, basically, you have to first make the use case diagram and then you find out the classes from that. So you will find out the nouns which are there in your step one is you will find out the nouns in your problem statement. You find the nouns you have read through the problem statement and associated documentation and highlight the nouns. Right, nouns you identify in the text or conversation with the client generally translate into classes or objects, attributes and attribute values. Right, and the verbs you identify in the analysis often reveal operations or associations, so that is there. Then evaluate the nouns to find classes. Now you see whatever nouns you have found out when you see the problem and you find out all the nouns. Now you see, identify from these nouns which are the classes you what are all the classes you want to make. So as an analyst you should ask questions to evaluate nouns to find classes. Is the term identified actually needed within the scope of the project or not? So you will see if this particular noun is part of it is used in the it can be used in the project. If needed, then does this noun qualify as a problem domain resource? If answer to point 2 above is yes, then think of an appropriate class name for the domain resource to which the noun is referring. Otherwise, find whether this noun is an example of a class, for example, an object or an instance of a class. So you will see it is an object or it is a class, whatever. Then you can see that noun is a attribute of a class or is it an example of an attribute. So you can take it as an attribute of a class, you can take it as a class name, whatever. So this way you define the purpose, that what is the purpose of the class, what the class will why the class is required. So that will be defining the purpose. So this is how you will find out the class different classes and their attributes and their name. Then they are talking about what is an object model. So here we have a simple object model of a university system with respect to different level of courses offered by the university. So the diagram covers different levels of student in the hierarchy. Similarly, for other classes such as administration and faculty, hierarchy level can be drawn to give a broader view of a whole system. So here they have made an object model where you will make a class diagram kind of a thing. So you have university, right? University is a parent class and you have three child classes: administration, faculty and registration and evaluation. So these are this triangle is showing that this is generalization and this is inheritance which is going on. So this is your parent class, university. It has three child classes: administration, faculty, registration and evaluation. Under registration and evaluation you have another child class called student. Under student, you have three child classes: PG student, diploma student, UG student. Undergraduate, diploma, and postgraduate. So these are the child classes of student, right? PG student have child classes like MCA, MBA, MSc, MA. Diploma student have child classes like PG diploma, UG diploma. UG diploma is also part of UG student also. So diploma student and UG student, these are the two parent classes of UG diploma. This is kind of a multiple inheritance, right? Accessing from two parent classes. Then UG student have undergraduate student have different child classes like BCA, BSc, BA, BCom. This is a object model for a university system they have drawn. Not a full detailed thing, but just a general form that how different levels of student in the hierarchy are shown here. That is what they have implemented here, object model. Right. Now they are talking about benefits of object-oriented orientation. What are the benefits? That means the features or advantages of object-oriented or benefits of object-oriented modeling. So one of the benefit is reuse. You can reuse the code, and emphasis on quality are the major highlights of object-oriented modeling. So then OM also provides resistance to change. Encapsulation and abstraction resistance to change mean that if there are changes in the software, you can do it. It can resist the changes. Encapsulation can be done. Abstraction is there, and due to its very nature, all these features add to the system development. So reuse is there, faster development is there, increased quality is there, easier maintenance, reuse of software and design framework, reduce development risk for complex system and integration. These are the your advantages or benefits which are there for your object oriented modeling. So this can be one of the question. Then the concept structure of object orientation helps in providing an abstraction mechanism for modeling. So your concepts are classes, objects, inheritance, association, which we have seen here also in the above, the different concepts here. So these are your basic concepts or conceptual structure of object orientation. Then they are talking about introduction to object oriented analysis and design tool. So your one of the main design tool means a mechanism through which you can analyze and design the object oriented analysis and design. So that is a unified modeling language, UML. UML is a tool, a software engineering tool, you can say, right? Unified modeling language is a well accepted language for OOAD, object oriented analysis and design. It is not that programming language. It is not a programming language. It is a modeling language to model, to design, to analyze, right? So that is for use for object oriented analysis and design. It is used for visualizing, specifying, constructing, and final documentation. UML is used for that. So the basic building blocks of UML used for OOAD are things, relationship, and diagram. Basically, unified modeling language focuses on the concept of BOOCH, OMT, and object-oriented software engineering. BOOCH methodology, OMT, and object-oriented software engineering. These were the three uh, approaches of object-oriented analysis and design. So it follows unified modeling language, follow all the three approaches. The result of these concepts is a single, common, and widely usable modeling language for users of these and other methods. So, unified modeling language also promotes the concept of what can be done with existing methods. So, many modern applications are being developed based on object-oriented principles such as classes, methods, and inheritance. For making the representation, these features of the system to be developed, some tools are used. So, these tools support UML features and building blocks. Object modeling case tools support object-oriented modeling notations, methodology. So there are many case tools available. One of the tool is UML, Unified Modeling Language. So they are talking about that. So in the later chapters, we will be talking about the different UML diagrams or UML modeling. How do these diagrams work? So we will be talking about that. So you may draw the UML diagrams on MS Word or Paint software, but there are certain tools available through which you can easily draw your UML diagrams, like you have Star UML. So for the practical sessions, you can download this software. Star UML is good, right? staruml.io from this is a website. You can go and you can download. It is an open source software, flexible, which can be used to draw the different diagrams in the practical sessions. When you want to draw a diagram, you can draw it on Star UML. So you can draw class, use case, component diagram, deployment diagram. There are different diagrams which are there. And Star UML is a multilingual project. So any programming language can be used to develop Star UML. For example, C, C++, Java, Visual Basic. All these languages can use to code through. You can code from this Star UML also. A basic concept will be there for that. Right, so it is multi-platform support. You can use it on Macintosh, Windows, and Linux. It is UML 2.x standard compliant, and you have entity relationship diagram, data flow diagram, flow chart, this and that. Then BOUML is another one which you can say. This is not an open source software actually. It runs under Windows, Linux, and Macintosh. It can be used for automatic generation of code from the UML class diagram and rebuild them from existing source code using these languages. So you can develop. It is not an open source software, right? So for if you use this one, if you make a class diagram, so you can implement that in that code in Java, PHP, and MySQL from this software by itself. Also, it can also generate for Python and Ideal also. Right. You also have one more software which is known as Visual Paradigm. It is a use case tool supporting UML2. It is powerful visually modeling tool that help you build and manage your diagram and model elements. This is another one. Agro UML is also there. It is also an open source, right? But it is using UML 1.4 diagrams. So right now you have two, but it is using 1.4. Then Magic Draw is there. So this tool has full support of all UML diagram. It fully supports UML 2.5.1, including class, and all those diagrams are there. Rational rows is there. This is a proprietary software, right? So again, you can use it, right? So you can download Star UML. It is limited uses there for certain days, so you can download this one also. So, or visual paradigm also if you want for making diagrams, so that they have given you. Then they have given you again check progress questions. What is association? Give example of association. What is multiplicity in association? Give example to explain multiplicity. What is inheritance? Give an example of multiple inheritance. So this is what they have given, and the answers to these questions are also given here. So what is association is given. It is a relationship between classes, and association describe link between among the classes. They have given you example. Multiplicity is association indicate the number of objects participate in a relationship, one or many, whatever can be there. Inheritance is an object-oriented concept. So they have explained inheritance also. This is there. This is your block unit 1, right? So any doubts in anybody is having in unit 1? Any doubt, anybody?
No, ma'am.
And then you have unit 2. Just so here in unit 2 again they are explaining UML, and then they are showing you the I'm not going through the details, but you can read them that modeling is a tested and well-known technique that helps build a model. So model is a blueprint of the real system that needs to be built. You may say that modeling is a necessity for designing software systems. So for modeling, you use UML, Unified Modeling Language, is a standard modeling language, and it is different from other programming languages. It is not a programming language actually. It is used for pictorial language, which is used to build model for the system. So UML is used to design models for large, medium, as well as small applications. UML was created by the Object Management Group (OMG), and the current version of Object or Unified Modeling Language is UML 2.5.1. Maybe that was released in June 2017. Right now, maybe more advanced version must have been added. So many tools like Star UML, Agro, Eclipse are available. So I told you you can download them. So they are giving you the details of the different diagrams which are there in your UML diagram hierarchy they have given you. So in the diagrams you have structure diagram and two types of diagrams are there in UML. One is structural diagram, the other is behavioral diagram. So structure diagram define the structure of the system, behavioral diagram are the functional part, the behavior of the system. The structural diagram you have class diagram, component diagram, object diagram. These are the and the deployment diagram. So these are the profile diagram, composite structure diagram, package diagram. We will not be doing. We will be doing class diagram, component diagram, object diagram, and deployment diagram. 1, 2, 3, 4 diagram under structure diagram. In the behavioral diagram, we'll be doing activity diagram, use case diagram, state machine diagram, and under the interaction diagram, we'll be doing sequence diagram and communication diagram. Right, interaction and timing diagram we will not be doing. Sequence and communication diagram will be doing under interaction diagram. So these are the diagrams which we are talking about. They have given you a hierarchy. What are the different diagrams which are there in UML? They have given you the hierarchy. So basically UML diagram denote two different views of a system model, a static and dynamic. So this structural diagram is the static view of the system, and behavioral diagram is the dynamic view of the system. Dynamic means behavior, the changes, and static means the structure or the structure or structural view. Static or structural view focuses on system static structure using object, attribute, operation, and relationship, right? And their behavior is the dynamic, right? Dynamic model. So behavioral diagrams are your dynamic model. That's what we have given you. There are many advantages of using UML. You may specify the structure and behavior of the system, which actually shows the blueprint of the system. It breaks a large complex system into separate fragments that can be understood easily. It can be easily grasped by the new team members. The UML model is not platform specific, hence it can be used by any developer who are working on different platforms. Right? So UML is a standard diagram, and through the diagram, a person can understand different things. Right? It is just a blueprint. It is showing the structure and the behavior of the system. So a new member can also understand the diagrams. That is the basic advantage of UML. Right, then basic structural modeling they are talking about. So modeling means creating a diagram for a system that includes identifying the elements that are important to your particular module. The structure modeling gives a structural view of a system that highlights the structure of the objects, including their classifiers, relationship, attributes, and operation. So basically, we have to modeling means we have to make a diagram or a picture of our system. We have to identify the structure, we have to identify the class, the attributes, the relationship, operations, and all that. So that is what we are doing in the modeling, right? So for example, if you are going to buy a car, things like wheel, frame size, color, lights, and engine are some things that will be worthful to you in understanding about the car. These things are properties of the car. So in UML, all of these things are modeled as classes. Cars can have external and internal structure. Only important properties of car are visible and rest are hidden. So this feature is called abstraction. So that means what we are showing a car's external and internal structure. So the important properties of the car are visible, rest are hidden. So that is what abstraction is. So class is an abstraction of the things that are a part of the vocabulary. So we in a class we are showing what all things are there which we need, right? The internal implementation or the details are hidden, but only thing we are showing that this class has these are the objects and these are the methods which are there. So that is what we will be showing here. So in this core elements of the structural modeling, we are talking about structural model. Structure means there are two types of modeling. One is structure diagram, the other is behavioral diagram. So in structural modeling, we have class, interface, component, node, constraint. These are the things. So a class is a blueprint for creating objects. It contains a group of objects that share the same properties, operations, and relationship. It contains three sections: name, attribute, and operation, like this. Right? Then interface, it is a collection of named operations that describe the behavior of an element. You can neither define any attribute nor any implementation of the operation in the interface. Only just you want to name the interface, so which is a collection of name operations. So you can just give a name here, interface name here within there. So this is the type of an interface which is there. Then component is the component is this thing. A component diagram is used to split the actual system into various modular parts. Each component has one clear aim within the whole system. The component can be a module, right? Component can be a module. So this is how the module is shown in or a component is shown in a system. This is the thing. Then node it is a runtime physical object that denotes a computational resource such as server, router. So if you have to show this in a deployment diagram, you have to show that this is the node, a server or a computer or whatever. So this is how a node is represented. Then constraint is a condition. Suppose there is a constraint on certain element or certain class, there is a constraint, then this is the notation for a constraint. Then this is a condition applied. So these are the different syntax or the different diagram pictures they have given you, right? So that is what we are talking about. So here they are talking about classes. So class describe a group of objects which have common attribute or properties or operations or behavior, relationship, and semantic. Classes are an essential structure of any object-oriented system. When you develop any system, you need classes to collect the system vocabulary. So class, we know that. So class have attribute and operations. So how do you make a class? A rectangle is there divided into three parts. This is your class name. Here will come your class name. Then you have attribute names, right? You can have plus and minus. I'll talk about plus and minus also. What does plus and minus mean? So here attribute or you can have attribute colon data type also. Attribute colon data type equal to value also. This also you can give. Then you have operation with the parameter or argument list, operation with argument list and return type also you can give. Only operation is also allowed, only attribute is also allowed, attribute with data type is allowed. Whatever you want to give, you can give. Like here, for example, if you have to graphically design a class, you have to make a rectangle with three sections, right, with name, attribute, and operations. So for example, a car class, this is a car class, the name of the class appears here in the first section, which contains the attribute maker name, wheel size, gear, frame size, color. These are the attribute, and operations like repair and move. With you see the circular brackets, repair and move have a function as a circular brackets. The same way we are giving here, operations or function will be here. So they have with circular brackets, they define the operations. This is how you make a car class. Following are some important points for creating a class. Each class must have a unique name. So you are giving a name. A class name is a textual string that comprises any number of letter, numeric, and punctuation marks. For example, car, book, teacher, whatever. A class may or may not have attributes. An attribute is defined by name that contains a series of values. A person have attribute like name, age, address, so similar kind of a thing. A class may or may not have operation also. So operations are describe the behavior of the class. Operation has a name like class name. Usually the operation name is written as a short text string that represents some behavior of the enclosing class. Like in car class, you have repair and move. A car moves and car can be repaired. Then you can also define the visibility of class members, attributes and operations. So I was talking about plus and minus. Plus means for public, minus means for private. So the access specifier here, if you have given minus, that means it is private to the class, and plus means it is public. That means outside can access. That is your plus and minus. And hash is also there. Hash is for protected, and tilde is also there. Tilde means for package. That means it is a part of a package or a module, right? We do not use tilde. If you want to use hash, you use, but it is used limited. We generally use plus and minus, that is public and private generally, and by default it is public. Plus only comes if you want to change it, you have to click it here and change to plus and minus. So if those people who are downloading star UML, they will find this kind of a structure in star UML for making a class. Then you have relationship. So relationship define how classes communicate with each other. There are three basic types of relationship: dependencies, generalization, and association for connecting or communicating classes to each other. So generalization, we know that it is inheritance, that one class, parent class having sub child classes. So we are showing it through generalization with a triangle towards a superclass. And dependencies, what is dependency? Dependency describes the relationship among classes in which one class is dependent on another class. That is dependency. It means that if you make changes in one class, it will affect the other class. For example, a class vehicle uses the properties and operation of another class, say body shop, but not necessarily the reverse. That means body shop is not using the operations of vehicle or properties or operations of vehicle, but vehicle is using the properties and operation of body shop. So you can show dependency as a dash directed line directed to the class being dependent upon the here like this. Vehicle is dependent on the body shop. A dashed line with an arrow towards body shop. This is known as dependency, right? Then we talked about generalization is a kind of relationship. It creates relationship between superclass, that is base class, and subclass, that is child class, or the this derived class, enabling inheritance of attributes and operations. So if you have to show it, this is generalization. A vehicle class is the parent class, and car and bus are inheriting from this parent class. This is inheritance with a hollow triangle pointing towards that. And if you want to show association, so association is a part of relationship between classes. It refers to relationship between classes in which objects of one class are connected to the other class objects for communicating data. So bus and driver are associated. A bus is driven by a driver, simple association. So that is there. You can also have two kinds of association, aggregation and composition also, which we have talked about. If there is one or more form of association is called aggregation, that specifies a whole part relationship between the aggregate whole and the component part. So if you have a whole part relationship, then you can show that a paragraph is a part of Word document, right? They have not shown it here. So when you have a Word document, this is whole, and paragraph will be a part of that whole. So that is there. A paragraph can be independent also, and paragraph is a part of the Word document also. So that kind of a thing. Aggregation, right? Then also you can specify the name and role and multiplicity also. So if you are talking about school and university, so school works for university. This is your association, a link, right? Association name is works for, right? And multiplicity is one or many schools work for one university. Here you can give one, and school is an employee and university is an employer. These are the role name. You can give that also if you want. So this is what they have given you, right? So that is there. Then common mechanisms they are talking about, like for design, during designing your application you might need to describe information through representations. This section explained to you some important terms or notations. Like I told you, if you have to give like IGNU program, so if you want to give a constraint or a note or a any note you have to give, or you want to give a condition or note. I'm talking about note right now, not condition. So you can give it in this thing, in this kind of a thing. This with a dotted line, it will come automatically. So this is note as embedded URL. So this is the URL they are giving in this. For IGNU program, you can go to this link. So for this, they have given it. If you want to give a stereotype, named stereotype, so like the last date. Last date means the last date for applying to this course. So this is a stereotype. So here, before the course name, the class name will come the stereotype name here. If you want to give the condition, this is the stereotype, that is the last date, and this is a condition. If you want to give the condition, that in the constraint you give a condition. So this is a constraint type. In curly brackets you are saying allow only one course per student. That means one course, one per student is allowed to apply. This is a constraint they have given. So this is how you can give a comment or a note. You can give a stereotype, that this is the last date to apply for this course, or you can give a constraint also, right? Common mechanisms you can use. So notes are used to define comments, explanation, documentation purposes, like this, right? The tagged value is used to create extension or new information or properties of UML element. Graphically, you can draw tagged value as a string enclosed in brackets. So you can also give a tagged value also if you want, in a comment also, in a note also. You have stereotype is used to create new building blocks. Using stereotype, we can use basic elements but with special properties, semantic and notation. So in double greater than and less than sign, you give a stereotype name like this. In this, you give a stereotype. Graphically, you can represent stereotype as text name inside elements and place them above the name of another element. So here they are given above the course name. You can give a constraint also. So if there is a condition defined, then you can give that condition in this constraint. That is what they have given you. Then they are talking about the first diagram, structural diagram, which is class diagram. So a class diagram is one of the most common diagram which is used to model object-oriented systems. The class diagram depicts a logical structure of the system. It shows classes, interfaces. Just hold on. Yeah. So, how do you draw a class diagram is how they are depicted here. Suppose, for example, they have shown you the class diagram for student registration system. So, for student registration system, they have shown university, school, faculty, student, program, course. These are the classes. So university class, the attributes of university class are name, address, phone number with the data type they have given, colon, data type string, address is string, phone is integer. Then the methods are add school, add student, remove student, get school, get all school, get student. These are the methods or operations of the university class. Right? Then school. Another class is school. The name of the school, the property is name with the data type string, and the methods or methods or operations are add faculty, remove faculty, add program, remove program in a school, right? So if you see, there are in a university you have different schools like computer science. Just hold on. Uh, So I was explaining about the classes. So these are the different classes. School faculties also have the attributes. Student has attribute, and then program have attribute, course have attribute, and operations. So these classes you are not seeing an operation. If you want, you can add operations. If you don't want to show the operations, so attribute and operation can or cannot be there in a class. So that is there. So if you see university and school have a relationship, you have to also show the relationship. So what kind of a relationship is this? This is aggregation. Schools are part of university. Schools can be separate also, and schools are part of the university also, right? So this is an aggregation relationship. Just hold on for a second. Yeah. So we were talking about that how schools are part of the university, right? So this is aggregation relationship, and they have also shown you the association that university has school. The name of the association is has, and the relationship here they are showing is one university have one or many schools. One colon colon asterisk means one or many, right? Same way with school and faculty, again faculty are part of a school, so again aggregation relationship, faculty can be separate also, and faculty can be are part of the school also, so they have shown aggregation relationship. Composition will be that fully dependent on a particular class, then it will be composition, not aggregation. That is a filled diamond, black diamond, but here it is association, not sorry, aggregation, not composition. So aggregation is a kind of relationship where part of is a part is of under whole. So school is a whole and faculty is part of. So that is what. So school is assigned. The faculty is assigned to a school, and again, one school can have one or more faculty. Then school faculty and course. That is a simple relationship is there. Faculty teaches the course, right? So one or more faculty can teach one or more courses, that can be there. School and program also have a relationship, right? You can name the relationship. Yes, school has programs, so one or more school can have one or more programs. And university and student have a relationship, again aggregation relationships. Student are part of the university, so aggregation relationship. One university can have many one or many students, right? So student register in university, so registration is the association name, and there is a constraint on the link association that one student per program. This is a constraint they have given. Can you understand this, how the class diagram is drawn? Any doubt in this? And there is another relationship which they have shown in school and faculty, that there is an HOD, one HOD from the faculty, right? So one school will have 0 or 1 HOD, head of department, head of the school. This is also they have shown. Is there any doubt in this class diagram? And they have explained here also. The thing I have explained to you, they have explained here also. Is there any doubt, anybody? Uh, Anybody has any doubt, please? I'm asking you.
No, ma'am.
No, ma'am.
So
It's
everybody
fine.
has put their attendance for this part of the class. We have another class right now only at 11. We'll take a 10 minutes break and do the. Anybody has any doubt?
No, ma'am.